All right, welcome back, calculus students. My apologies, there were some technical difficulties. So this video or this lesson is going to be split into two videos. Hopefully, there's no more issues after this point. Let's look at the problem number 3. Water is pumped into a tank at a rate of, water is pumped into a tank at a rate modeled by R of T in liters per hour, where R is differentiable and decreasing on the interval from 0 to 8. Selected values of R of T are shown in the table below. At time T equals 0, there are 5,000 liters of water in the tank. So what does the integral from 0 to 8 R of T dt represent in this situation? So what are we talking about? We're talking about water being pumped into a tank at some rate, and then the time 0 to 8 represents the hours, right? And it's decreasing. So that means the amount of water being pumped into the tank in an 8-hour period, right? So that's basically what this means, right? We're not going to think too much about it. It's just what this represents in this context. So it's amount of water pumped from 0 to 8 hours, or from a 0 to 8 hour period, right? Estimate the left Riemann sum of this integral. So we're going to do the left Riemann sum. Hopefully you don't forget what this is. I'm going to go ahead and start us doing the equation, right? We're doing the left side, right? So we're going to be using these values, 1, 2, 3, 4, right? Because technically I can take 8 and divide it by 2 equal intervals, so divided by 2, that can be 4 sections, right? So I'm only going to use 4 sections to find how much using the left Riemann sum. So I'm going to go ahead and start this off by saying it's going to be 3,000 times 1. Why is it times 1? Well, because the distance between here and here is 1, right? So now plus 2 times 2,500. And how did I get that distance? The distance from here to here is a distance of 2. Here's a distance of 1. So the next one, guess what it's going to be? Plus 3 times 2,100. Again, the distance between here and here is 3. Okay. Plus the distance between here to here, that's 2. So it's going to be 2 times 1,500. Boom. Okay. So now I go ahead and figure this out. This is going to be 3,000 plus 5,000 plus 21 times 3. Was that going to give me 63? 63,000. Well, 6,300. My apologies. Been a long weekend, so if I'm saying numbers incorrectly, that's probably the reason. Times 2 times 1,500, that's going to be 3,000. I add this all together, and that should give me a value of approximately 17,300. And what are we talking about? We're talking about liters. Okay. Again, that was using the left Riemann sum method, right? Again, the value here was 2. Based on the estimate, how many liters of water are in the tank after 8 hours? So after the full 8 hours are, taken into consideration, I want to go ahead and look at everything as a whole, right? So I have the 17,300 liters, 17,300 liters. And again, this was using my left Riemann sum method. But guess what? How many liters of water did we start with in the tank? We started with 5,000. So I'm going to just literally add plus 5,000. Because that's how much total liters of water we dealt with. So in the end, we actually just dealt with, or we have a total of 22,300 liters. My apologies again for reading the numbers incorrectly. Here we go. So we're done with number 3. Let's move on to number 4. If you have any questions, move on to, pause the video and come back and watch it a few times, or feel free to send me an email. All right, let's look at number 4. It says the same scenario, but this time the table of values represents W of T, the number of liters of water in the tank at a given time, T, measured in hours. So now we're looking at the number or the amount of gallons at that time. We're not looking at how much it increased by. So it says, what does the integral from 0 to 8 W prime T dt represent? So I want you to notice, we were not given W. We were given W prime. W represents the value, the number of liters in the water in some given time interval. But now, W of T represents the rate in which we're getting that. But I want you to notice, we're taking the integral. So if I'm taking the integral, that's the antiderivative. So I'm really asking you, what does W represent in a very complex way? Again, this is going to seem very, how do I say this? It's going to seem very weird to say, but this is actually the same thing as before. It's the amount of water. Whoops, here we go. Amount of water pumped during an 8-hour period. And this makes sense because if I'm taking the antiderivative of W prime, I'm going to end up with W, right? Now the next one for part B says find the integral 0 to 8 of W prime T dt. So now, when you're evaluating your integrals, we know I have W of T. So W of T would be the antiderivative of W prime T. And I'm evaluating it from value 0 to 8. So that means I got to take W of 8 and minus W of 0. So I look at my table of values, and I'm going to do 22,000 minus 5,000. And that's going to give me 17,000 liters. Okay. So that is it. That's how much liters I have once I evaluate that integral. Let me know if you have any questions for these videos. I think there's going to be a delay for 8.4. I'm going to probably upload it sometime later today just because my computer's been giving me some technical difficulties and I want to get those fixed. But I promise I will have the video for 8.4 uploaded sometime today. The videos for 8.5 and 8.6, I'm going to be uploading them on Wednesday. So be on the lookout for those videos on Wednesday, okay? So hopefully you enjoy your spring break. Practice these lessons. For this lesson 8.3, I would like for you to really take your time and do the practice. Do not cheat, some of you cheaters out there. But try to set up the equations for most of the practice problems. I encourage you to try at least 1 to 6 or 1 to 7. Yeah, 1 to 7. 1 to 7 is fine. Do 1 to 7. 1 to 7 should be fine. If you want to double check your answers, you can double check your answers. But again, I would like for you to try them first before you start just going into the answer key and looking for the solutions, okay? So I want you to really try this. Next time I see you, we're going to be doing 8.4. Again, expect 8.4 to be uploaded sometime later tonight or in the evening, just because I want to make sure I have everything organized and fixed on my end, okay? I'll see you in the next video.